Welcome to my Cisco Routing and Switching Essentials. We are looking at Lab 6336, Designing and Implementing a VLSM Address Scheme. So, first thing I want to do is look at my instructions. And so, I preset this up in Excel for us. So, we're going to be answering these 4 questions initially. So, what I did was, I noticed the numbers are all less than 256. So that means we're working only in the 4th octet. And so what I did was I broke the 4th octet up. So we're going to be looking at switch 1, switch 2, switch 3, switch 4. And we're looking for what will fit 27. So actually what I'm going to do is I'm going to change this over a little bit. So does 27 fit into 1? No. Does 27 fit into 2? No. No, 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 yes. The second we get a yes, everything to the left it will fit into, so we are good there. And so we convert this back to decimal. So 128 plus 64 is 192 plus 32 is 224. So the IP, or the subnet mask that will handle this requirement will be 255, 255, 255, and these 3 added together, which would be 224. So we're going to do the same thing for this guy. Start the far right. Does 25 go into 1? No. 25 into 2? No. 25 into 4? No. 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 Yes. And so it'll be the same thing all the way down. So the same subnet mask will accommodate 25. All right, for switch 3, we are doing 14. So what we're going to do for 14 is same general steps. Does 14 go into 1? Does 14 go into 2? Does 14 go into 4? Does 14 go into 8? Does 14 go into 16? Yes. Everything to the left of that will be yes. And again, we take these and we convert them back to decimal. 128 plus 64 plus 32 plus 16 should give us 240. The next one will be support 8 hosts. Okay, so this is where a little forethought has to come into play. If it says the word hosts, we should automatically be adding 2 to everything because we know we're going to be losing 2 later down the line. So I'm going to do switch 4 2 different ways. I'm just going to take it using 8 IP addresses, and then I'm going to do the same thing but 8 usable. So 4, because there's a slight difference between the 2. So I do want to point that out. Does 8 go into 1? Does 8 go into 2? Does 8 go into 4? 8 does go into 8 though. Again, take these, convert them back to decimal. 128 plus 64 plus 32 plus 16 plus 8 should be. Alright, so because it says hosts, I'm going to assume it means usable. We are going to be removing 2 later down the line, for one for the network and one for the broadcast, leaving only 6 usable. So I'm going to add 2 to this, making it 10. Does 10 go into 1? Does 10 go into 2? Does 10 go into 4? Does 10 go into 8? Does 10 go into 16? Yes. Convert it back to decimal and should be 240. I was actually, I do this automatically in my head, so I did forget to mention it, because I automatically added 2 to all of these. when I was doing my numbering. So it's just kind of something that I forget to say. So which subnet will accommodate the IP addresses for this? So for switch 1, we're looking at the last one. How many usable hosts will we be allowed? All right, so what I'm going to do is usable hosts. Our last one is 32. Minus 2 will give us 30 usable. Switch 2, again, 32 minus 2 will give us 30 usable. Switch 3 will give us 16 minus 2, 14 usable. That's what we needed. We needed 14 usable. Switch 4, using it the first path, 8 minus 2 will give us 6 usable. Oh, that doesn't work. We need at least 8 addresses to assign to hosts. Because I added the 2 at the very beginning, we're going to do the next one, which is 16 minus 2, which will give us 14 usable. So these ones work were the addresses that we were given. So those are step 2 all the way done. So let's divide this network based on the number of hosts per subnets, and let's figure out how we can do these steps. Okay, one last step. Well, we got to double check E between remote sites. So I'm going to add one more network in here. Remote sites, they should require 2 actual IPs, so we're going to add 2. So does 4 go into 1? Does 4 go into 2? Does 4 go into 4? Yes. So convert that all back to decimal, and it should be 252. Again, remote 4 minus 2 will equal 2. We needed 2 to begin with, which we got, so we are good there. So that completes step 2. Now let's move on to that completes part 1, step 2. Now let's go on to part 2, step 1. So we're going to be dividing this network up into 5 different chunks. And then we're going to ask ourselves, well, how can we do our subnetting based off of that? So what we're going to do is we're going to rank these greatest to least. So this network didn't work, so I'm just going to get rid of it. It's gone. So we're going to rank them switch 1, switch 2, switch 3, switch 4 usable, and remote. So those are the networks that we have because we rank them greatest to least on host count, which that just happens to be the ones we already had pre-set up. And those are our numbers. So what we're going to have to do is, okay, so we're going to do breaking this network up. So notice I did this little chart. So first, I'm going to call the top the host count. And then I'm going to call the second group the block/group size. So I'm going to start with the number 1, and I'm just going to keep doubling. 16, 32, 64, 128. So one of the issues with subnetting is people take this concept and they don't quite go far enough with it. So what I'm going to do is just that. I want to combine my numbers a little bit so that we can see everything. And this is going to be our boundary. Well, the issue is we're going to keep doubling. 256, 512, 1024. Okay, apparently Exchange doesn't, or Excel does not like that. 1024. Okay, I just redid that really quick in Excel. So our host count, you're going to notice, is continuously doubling. We start with the 32-bit, which is 1, and we double it. So the 30th bit is the 30, sorry. We start with 1 and we double. 2, 4, 8, 16, 32, and we just keep doubling. This is the 32nd bit, 31st bit, the 30th bit, and so forth. Because again, an IPv4 address is 30-bit or 32 bits long. And we broke them up into 8 groups. And we did that for all of the numbers. So 30th, or the very first bit, all the way down to the 32nd bit. And you're going to notice that our host count keeps going, doubling. 16 million, 33 million, so forth, so forth, so forth. If we actually want to see what these are, there is no decimal spot like that, so let's get rid of them. 134 million. 2 billion, so forth. We normally are not working with the first octet though. Sometimes the second, but mainly we're going to be working with these octets. You're going to notice that the block group always repeats itself. And that's how we figure out our blocking. So let's assume we had a subnet that was in the second octet. We happen to have a subnet that was 11111 dot. We'll say slash. It was a /10. So that would be 255.192.0.0. 255, 128 plus 64 is 92, and everything else zeros. What we would do is would be looking at the block size. So we're looking at this guy right here. We're looking at where the last one is, and that would be groups of, or block sizes of 64. That meant when we went to do our subnetting, would be doing groups of that block size. So I wanted to point that out so that we understood that concept when we were working on this portion right here. So we are using this subnet. You'll notice that everything is going to be done in the 4th octet. So what I'm going to do is 172.31.103, and we're going to start with 0. So we start with 0. Well, what's the first number? How do we get past the first subnet? what I'm going to do, actually, I'm going to move this down. So switch 1 will have this beginning network ID. We happen to know that the last bit was here, so we're going to increase by 32. So the next subnet will be 172.31.103, and we're increasing by 32. All right, so we're looking at switch 2. That will be switch 2's network ID. We look at the subnet for switch 2, which again happens to be also 32. So it will be 31.103, and we're adding 32 again. So 32 plus another 32 should be 64. All right, so we've done switch those two guys. Now we're moving on to switch 3. Switch 3 happens to be this subnet. So we're going to be adding 16. 172.31.103. 64 plus 16 should be 80. Again, switch 4. The last number is in the 16 size, so 172.31.103. We add 16, should be 96. The last network, we're adding 4, because that's where the last one is. So 172.31.103. Add 4 to 96, it'll be 100. So these are our network IDs. I'm going to skip the range, and I want to do our broadcasts. So I'm going to be a little bit lazy. We know those numbers are staying the same. So how do we figure out the broadcast? We notice that all of those numbers are identical. So what we're going to do is, for this column, I'm actually going to make this a little simpler so that we can separate everything. The broadcast is one less than the next ID. The next ID is 172.31.103.32. Well, we're going to be removing one bit from the far right-hand side, which happens to be 32, which we can remove 1 from 32, and that becomes 31. So our broadcast for that network is 172.31.103.31. We go to the next network. You get the broadcast. We look at the next ID, it happens to be 64, and we subtract 1 bit from 64, 63. Same thing here. We look at the next ID, and we subtract 1. 1 from 80 is 79. We do the same thing here. We look at the next ID, which is 96. We subtract 1, that becomes 95. We look at the next one, which will be 100, and we subtract 1, will be 99. And that's it. Those are the 5 networks that we need. So why did we do this network right here? We did this one so that we could get this number a little simpler. That's it. I'm going to go ahead and box that up. So now, how do we get the range? The range literally is everything in the middle. The first 3 octets are staying the same, so we want everything between 1 on this side and 30 on this side. We can't use 2 because we can't use 0 because 1's already taken. So we can do 1, 2, 3, 4, all the way to 30. Can't go above 30 because 31 is our limit. Here we have between 33 and 62. Here we have 65 through 78. We have 81 through 94. We have 97 through 98. So we've actually been able to do this entire chart. So align the first usable IP address to R1 or to the remote site 1. First usable for our remote network, it happens to be this one. Our second usable or our last usable will be that number. So let's go and do some basic configuring of our IP addresses. Remember that this beginning portion of the network ID is always there, even if I don't write it, because it's still there. I just kind of got lazy. Because these numbers are still there. So what I'm going to do is I'm going to take this chart I'm going to insert a new row. And organize this a little bit better. So this right here is our range. So this entire thing is our range. Configure the IP addresses. So we can take this chart and we can do these areas. So what I'm going to do is use snippet so I can have this up. And we're going to go configure some of these addresses. All right, so let's go ahead and configure the IP address on this guy right here. So we're going to hop on R1, get to our CLI, get to our configuration. Oh, helps if I spell it correctly. Let's get to our configuration mode, enable, configure terminal. Let's go ahead and do some basic configuration. So we should be configuring switch 1. Which should be the gigabit 0 interface. So int G0/0. The IP address is IP address. First usable happens to be this guy right here. So IP address 172.31.103.1. Subnet mask is 224. We're going to program the next interface. Interface gigabit 0/1. IP address. Oh, hit enter too soon. That should be the next IP address. 172.31.103.33. Subnet mask is 224. 224. And we should be good. Well, the instruction said configure the IP address, not to turn them on. So let's go ahead and go back and let's turn them on. No shut. Yeah, because following the instructions sometimes is not always the best because again, the concept of the instructions as opposed to what they're intended to say are slightly different. So that part's done. Let's configure the IP address on switch 3. We're going to be using the router as our default gateway. Alright, so switch 3 will be using this network range. So CLI, get into its configuration mode, so configure terminal. We're going to be setting up the default gateway, so IP route. We want to match everything, and we're going to send it to 172.31.103.65. Because we're doing a switch, it does not always like our IP routes. Sometimes what you have to do is, instead of IP route, you can do the IP default gateway, and 31.103.65. Oh, we're doing a default gateway, not a route again. So it will just be default gateway and the IP address. I always get in the mindset of doing static route, so I always do the INIs. But yeah, IP default gateway, that will go to that guy. So we've done those two. The last one is configure IP address on user 4 and include the default gateway. So this happens to be the IP address we're assigning the router. And it said last usable as our IP address, so 172.31.103.90. Sorry, we're doing this one right here. 94. And make sure to do the appropriate subnet mask for this network, which for switch 4 is 240. And the default gateway should be the should be the first usable, 103.81, because we're using this range. Make sure to type in the range, 103.81, and that should be it. So those steps are done. So we should be able to ping between those networks now. So let's actually try to ping a user, of course. Let's try pinging at least one of the IP addresses that we set up. So 172.31.103.1. That guy works. Dot 33. That guy works. Dot our gateway, which is 81. So all of our addresses work. So we are good. And we should be able to check results. And it did not like our switch 3. So I'm going to go back to switch 3. I'm going to go to interface VLAN 1. Nope, interface VLAN 1. I'm going to assign it the last usable 172.31.103.70.78, and make sure to do the appropriate subnet mask, 240. Turn it on. But we should get a duplicate address. Oh, sorry, I did not read correctly. Assign the second usable to the switch. So we don't want 78. We're using this network ID. We're going to be doing 66. First usable is going to the router. Second usable is going to the switch. All right, so now we should be able to check our results. And everything is 100%. So this lab took a little bit of time, especially with the numbers, but we were able to get through it. Thank you.